Today, we're going to look at analyzing special systems. So we've already looked at how we can take two lines, graph them on the same graph, and see where they intersect to form a solution. So as you can see in this figure up here on the far left, that's exactly what I was just talking about. Two lines, the red and the blue. It says lines that intersect at one point. We call that intersecting and getting one solution. Okay, so anytime two lines intersect at one particular point, that would be one solution. And then we could name that ordered pair, which is that solution. There's another type of system where we end up getting infinitely many solutions. Infinitely many solutions means that you end up with multiple lines that actually are the same line. So lines that have the same slope and y-intercept. The third and final way for us to have solutions would be when there's actually no solution at all. As you can see in this picture, we have two lines and they are what we call parallel. Parallel lines never intersect. They have the same slope and different y-intercepts. And so that's why they would be no solution, because there's nowhere that those two intersect to form a common point. So I kind of already said it, but I just want to one more time state it in words. How can you tell the type of solution by an equation? And that's what we're going to be looking at today. Can you rearrange the equations to get them into slope-intercept form? And from that point, right now we're not going to actually graph them, but we're going to look at the characteristics of those lines to determine how many solutions there are. So once again, you would have one solution if you have two different lines intersecting. So basically, when we're looking at the two lines, we have to have two lines with different slopes. Okay, they could technically have the same y-intercept, but their slopes have to be different, having them go in several different directions where they could potentially meet up at one point. So to have infinitely many solutions, this is where you're going to have two lines with the same slope and the same y-intercept. So essentially, you have the exact same line if they're both the same slope and the same y-intercept. And then you'll have no solution at all if you have two lines with the same slope and different y-intercepts. All right, so it's going to be important that we not only can get our equations into that y equals scenario, but then we have to know, okay, what is my slope? What is my y-intercept? So then we can compare it to these three types of situations to determine how many solutions we have. So let's start looking at some examples. So we are going to determine if the system has one solution, no solution, or infinitely many. So notice for us, this very first system, that top line right there already says y equals. So it might be a good idea. So here's the first line, there's the second line. So if I'm identifying the first line, since it already says y equals, we don't have to turn it into slope-intercept form. It's already there. But I do want to know, remember, m stands for slope, B stands for y-intercept. It's important to know what those two things are. So the number that is connected to the x is going to be your slope. Notice that 3 is not only connected to x, but technically the negative sign in front is. So -3 is going to be your slope. The number that is not attached to the x, that's your y-intercept. And remember, as an ordered pair, it's always 0, comma, whatever that number is. So there's my slope, there's my y-intercept. So now if I look at the second line, this one, I'm going to have to do a little bit of work because it does not just say y equals, it says -2y equals. So my first step then is, how do I get it just to say y? Since -2 is attached through multiplication, we are going to have to divide every single thing in that equation by the number that's attached to the y. So I divide everything by -2. That gets me the y by itself. Technically, there's a 1 with that x. 1 divided by -2 is going to stay a fraction. I'm just going to then keep it as -1/2. X is still with it. And then notice that 4 divided by -2 is -2. And now that I have that into slope-intercept form, I can identify my slope. I can identify my y-intercept. Once again, slope is attached to the x, so that's that -1/2. -2 is the number not attached to x, so as an ordered pair, that would be 0, -2. So notice with both of those lines, the slopes are not the same and the y-intercepts are different. So if we go back up here, notice that in infinitely many solutions as well as no solution, notice that you have to have the same slope. But with one solution, you have two different slopes. So because these slopes are different, we're going to say that we have one solution. All right, and that would be my answer for today. Like I said, we're not actually going to graph them and determine that solution quite yet. We're just going to compare those two equations to determine how many solutions. Let's take a look at the next one. Here we have two different equations, so I'm going to number them equation 1, equation 2. We have to make sure that they are in slope-intercept form for us to identify the slope and the y-intercept to then determine how many solutions we have. So hopefully we notice that because that top equation does not say y equals, we have a little bit of work ahead of us. I got to get the y by itself. Since -x is on that side, I'm going to do the opposite, which means I'm going to add x to both sides. I'll still have that -y. Now, because those are not like terms, I'm going to put the x first. It's positive, so there's no number in front. Notice that the 3 is negative, so -3. And because then I technically have like a -1 in front of the y, I'm going to divide every single thing by -1. That gets you the y by itself. X divided by -1 would be -1x, and -3 divided by -1 would be +3. Now that I have it into slope-intercept form, we can identify those two things. The number that is in front of the x, which is -1, would be your slope. 3 is the number that then, as an ordered pair, would become 0, 3, and that's my y-intercept. If I look at the second equation, it does not quite have the y by itself. There is a negative sign in front. So just like the last equation, we first have to get anything that's on the same side as y to the other side. If you want, like the last problem, to put a 1 in front with the negative, we're going to divide every single thing by -1. That gets the y by itself. -3 divided by -1 is +3. And x divided by -1 would be -1x. If we then identify our slope and our y-intercept, the number that is in front of the x is our slope. Notice that it's not only the 1, but it's technically -1. 3 is the number that is not attached to x as an ordered pair. 0, 3 would be my y-intercept. Notice that from both of those equations, the slope and the y-intercept are the same. So going back up here to our three different things, notice that when you have two lines with the same slope and the same y-intercept, that happens to be infinitely many solutions. So that would be how many solutions we have. And infinitely just means that every single ordered pair is a solution for both of those equations. All right, if we take a look at the next example, we have two equations. Notice that both of these equations do not quite have y equals, so we'll have to do a little bit of work. So with my top equation, in order to get the y by itself, I'm going to have to divide every single thing by 2. That will get us the y by itself. 3 divided by 2. That's not going to turn into a nice number, and I'm not going to be able to simplify that down. 3 and 2 don't have any numbers in common, so I'm going to keep it as 3 over 2. There's still an x with it. Notice that negative 2 divided by 2 turns into negative 1. So now I can identify my slope and my y-intercept. Slope is the number connected to x. That would be my fraction here, so 3 over 2. The number that's not connected as an ordered pair would be 0, negative 1 for my y-intercept. Looking at the second equation, we have to, once again, get y by itself. So just like the last problem, since 2 is attached to y, I'm going to divide every single thing by 2. That gets us to have y equals, similar to the last example there, negative 3 divided by 2. That's not going to divide nicely. It's not going to simplify down any further. So negative 3 over 2 and then x with it. Notice that 6 divided by 2 is positive 3. So my slope is negative 3 over 2. My y-intercept is the ordered pair 0, 3. Okay, so notice that in this example, my slopes are different and even my y-intercepts are different. So once again, going back up here, 2 lines with different slopes tells us that we have one solution. That means that those 2 lines would intersect and we'd be able to figure out an ordered pair where they connect. Looking at this next example, we've got, once again, 2 equations. They do not say y equals, so we've got a little bit of algebra ahead of us here. So if I take that top equation, the nice thing about this is the only number that is connected to the y is negative 1, but it's not really connected. So that means that we're doing addition or subtraction, not multiplication or division. Because it says negative 1, the opposite of a negative is a positive. So I'm going to add 1 over. So now it's y equals, those are not like terms. I like to put the x first. So that's still negative 2x plus 1. So now I can very easily identify my slope. It's the number that is connected to my x. So that would be negative 2. My y-intercept is the number that is not connected. So as an ordered pair, that would be 0, 1. Looking at that second line, negative y, minus 2x equals 4. All right, so got to get that y by itself. Since x is on the same side, we have to move that first. So the opposite of a negative 2x would be a positive 2x. We'll still have that negative y. Those are not like terms. I like to put the x term first since it was a positive 2x. Now I just have positive 2x. That 4 is positive, so I'll plus 4. If you want, put that little 1 in front of that. So negative 1 is what's attached to the y. So negative 1 is what we'll divide every single thing by. That gets the y by itself. 2 divided by negative 1 is negative 2. There's still an x with that. And then 4 divided by negative 1 is negative 4. If we identify our slope and our y-intercept, slope is connected to the x. That would be negative 2. Y-intercept, be careful, it's not just 4, it is negative 4, so 0, negative 4 is that y-intercept. Notice if I start comparing slope and y-intercept, slopes are the same, the y-intercepts are different. So going back up here one more time, slopes are the same, means it's either infinitely many or no solution, but notice here, no solution says the y-intercepts are different, and since that's our case, that tells us that we have no solution. So if you feel like these 4 problems are good enough for you to then start the homework, feel free to stop the video and you can start on that. I'm going to just continue. I have 2 more examples here. So feel free to watch these last 2 examples before trying the homework if you feel like you need a little bit more of a video. Okay, so I'm going to once again start by getting these 2 equations to say y equals. So the top equation has several things on the same side as y. First thing you want to move is something that's not attached. So that negative 16, I got to do the opposite. I'm going to add 16 over to the other side. That still has a negative 4 in front of that y. And 16 and that negative 7x are not like terms. I like to put the x term first. So then now that negative 4 is attached to the y, I can divide every single thing by negative 4. That will get us the y by itself. A negative divided by a negative is a positive. So because 7 divided by 4 won't get me a nice number, but I can divide a negative divided by a negative, that fraction actually then becomes positive. And then 16 divided by negative 4 would be negative 4. So in this equation, notice that my slope is what's connected to x, so that's 7 over 4. My y-intercept would be then that 0, negative 4. If I look at the second equation here, negative 16 plus x equals negative 4y. Notice that even though the y is on the right-hand side, it's almost by itself. So the only thing I have to do here is divide everything by negative 4. So here I've got negative 16 divided by negative 4. A negative divided by negative is a positive. So 16 divided by 4 is 4. If you want, think of that number as a 1 with the x, and 1 divided by negative 4, we'll keep it as negative 4, but x is with it, and that equals y. So it's backwards, so if you want, flip it around. It's y equals, I like to put the x first, so it's negative 1/4 x. That 4 was positive, so plus 4. So now notice I can identify that slope. It would be negative 1/4. My y-intercept is the ordered pair 0, 4. So notice since my slopes are different, and even my y-intercepts are different, but the moment my slopes are different, that tells us that we have one solution. All right, last example. So once again, I'm going to make sure that my equations are solved for y. So the top equation, 2y equals 3x minus 8. In order to get y by itself, I'm going to divide by 2 to everything in that equation. So that gets me y equals 3 divided by 2 is not going to simplify down any further. Negative 8 divided by 2 gives us negative 4. So my slope is 3 over 2. And my y-intercept is the ordered pair 0, negative 4. Looking at this second equation, notice that all of my terms are on the same side. So actually, the fastest way to get y by itself is actually moving the y over to the other side. Since that is a positive 4y, the opposite of a positive is a negative. So I'm going to subtract 4y over to the other side. That still leaves you with the negative 6x plus 16, and now that equals a negative 4y because 0 minus 4y, if there's 0, then nothing changes besides what you moved over there. So now my last step to get the y by itself is to divide by the number that is attached to it, which would be negative 4. Okay, so notice that negative 6 divided by negative 4, well, a negative divided by a negative would be a positive. So I'm going to have a positive fraction. But 6 and 4 have something in common. They're both divisible by 2. 6 divided by 2 is 3, and 4 divided by 2 is 2. So that actually reduced down to a positive 3/2. 16 divided by negative 4 is negative 4. And that's y. So if you want, once again, you can flip it around. So y equals 3/2 x minus 4. So if we identify our slope, notice it's 3/2. Our y-intercept is 0, negative 4. And not only is our slope the same, but our y-intercept is the same, which means that we have infinitely many solutions. So hopefully these helped you out. And like I said, start on the homework and let me know if you have any questions.